In this video, we're going to talk about the inductors and how they affect the circuit. So we're going to answer 4 questions. Number 1, what creates inefficiency? Why is that inefficiency created? How is it created? And also your solution for the inefficiency. So this is in 4 parts. What's creating the inefficiency? Inefficiency is created, that's something that's added inductor or capacitor to the circuit. Since our lesson was on inductors, right, our inductors create the inefficiency, okay? Because they create a different dimension into the circuit, right? Okay, that's number 1. Number 2, why? The reason is you have mutual inductance, right? So you have all this mutual inductance that so because you have mutual inductance, right, to preserve the energy. So the mutual inductance simply preserves the energy as the electricity comes from the utility to the transformer into any kind of building. So mutual inductance are actually required, right? You really don't want to lose them, okay? But what happens is that, and because they're required, because they preserve energy. They're preserving the energy of this as the voltages drop or increase or currents drop or increase, they preserve the energy, right? By the magnetic field, by containing the magnetic field, okay? However, it creates an inefficiency in the circuit. You don't lose energy, but this is the good part, but the bad part is, but it creates inefficiency. So there's really no going around the inductor, okay? You have to use the inductor, but unfortunately it will create the inefficiency. So think about it like this, right? Think about it in terms of, you have, when you go to work, you work 8 hours a day. If you travel 1 hour to work and 1 hour back from work, well, you got to travel, right? So you have to waste those 2 hours of inefficiency to get to your destination and work 8 hours, right? So think about it that way. Now, how does it create inefficiency? So this requires a little bit of math, okay? So we're going to look at, let's say, we know that our Z equivalence is equal to ZR plus Z of L, right? And let's just say our real component is 100, and our imaginary component, it'll be J100. We went over this in class, where that J100 comes from, okay? Now, understand that this is on the real number line, and this is on the imaginary y-axis. So consider anything that doesn't have these J or imaginary numbers is on the x-axis, okay? And anything with imaginary numbers is on a different y-axis. There's 2 different axes, or axes, right? So let's draw this out. So what we're going to do now is I'm going to draw a triangle, and I'm going to make a J, huge 1,000 there, right? And I'm going to make a J 100 here. And I'm going to make a J and a small 100 here. And so what we're going to do is we're going to create an angle. So this is going to be 100, 100, and then 100. This will be J1000, J100, and J10, right? We're going to just decrease the inductor as we go. Okay, so we're going to create a triangle, and in this triangle, we have an angle. Okay, we have an angle, and in this angle, we have the certain components. Okay, one component is we're going to, obviously, a little trig, right? We have to figure out what that angle is. So what's that angle? We remember sine, cosine, tangent, right? So we're going to go ahead and calculate this angle as 1,000 over 100. We're going to calculate this angle as, and then you're going to calculate this angle as, okay? So let's first get the angles. So the angles of this are the following. Okay, so you can take out your calculator and then we can just operate the calculator here, all right? Make sure your calculation is in degrees. This kind of says degrees in really small writing here, but it has to be degrees. It cannot say radians, okay? And we simply take 1,000. Here, I don't know if you can see it. Should turn the light on a little bit here. Okay, let's put the calculator here. That's better, right? Yeah, 1,000 divided by 100. And I'm going to take the second tangent. Sorry, hold on. Second tangent of 1,000 divided by 100. And you get 84.26. So this angle is 84.26. Okay? Let's do this one. Arctangent of, sorry, I'm going to go ahead and take this out. The arctangent of 1. So basically, if you go second tangent, 100 divided by 100. 45. And second tangent was 10 divided by 100. And this is 5. So you can, this is 5.7 degrees, 71 degrees, or 5.71 degrees, 84.26, and 45 degrees. So now what we want to do to calculate the efficiency of something, right? We have something called a power factor, right? I'm going to move this up a little bit on the screen. So our power factor is cosine of this angle, right? So cosine of this angle. So our cosine of 84.26. Cosine, which is our power factor, which is 45. Cosine, which is 5.71. Okay, so let's go ahead and do that. So you take cosine of 84.26. This is about, your answer is 0.1, right? If you can see it, it's 0.1. So this is 0.1, and I'll draw a line through this here. Our cosine of 45 is 0.7, as you can see on our calculator, 0.7. And our cosine, 5.71, is 0.99. Right? So this is what, 0.1, that's 10% efficient, 70% efficient, and 99% efficient. Okay? So this is the understanding of, as the inductor increases, as we increase the inductors, then it makes it less efficient. As you decrease the inductor, you make it more efficient.